Hello students, let us continue the session on polynomials. I will be solving the last question of the exercise 2.4. For which values of a and b are the zeros of q of x equal to x cube plus 2x square plus a. Also the zeros of the polynomial p of x equal to x to the power 5 minus x to the power 4 minus 4x cube plus 3x square plus 3x plus b. Which zeros of p of x are not the zeros of q of x? Slightly tricky question. Here we need to find the values of a and b. The zeros of q of x are also the zero of the polynomial p of x. So it means that this p of x is completely divisible by q of x. So that gives a hint to go for long division. Let me divide p of x by q of x. So I will take x cube plus 3x square plus a as a divisor, and I will divide x raised to the power 5 minus x to the power 4 minus 4x cube plus 3x square plus 3x plus b. This polynomial p of x is of the degree 5. The polynomial q of x is a cubic polynomial. So what should be multiplied to this first term, to x cube, to get x to the power 5, x to the power 2 to be multiplied. So we get x raised to the power 5 minus, it is plus 2x to the power 4. If I multiply this x square to a, we get a times of x square, but then you observe here there is no cube term. So in the place of cube term, I will leave it blank. Then I will write below x square term plus ax square. Now we will follow the same method. We will change their sign and add them. So the first term, x to the power 5, they get cancelled. Minus 2 x to the power 4 minus x to the power 4, when you add them, you get minus 3 x to the power 4. Now this cube term you have to retain as it is. So minus 4x cube. Now very carefully you observe, to add this 3x square to minus ax square, I will better take x square as common, and the remaining term I will write as 3 minus a times of x square. Now the 3x and b is taken as it is. Now what should be multiplied to x cube to get minus 3 x to the power 4? Probably you have guessed it right, it is 3x. If you multiply minus 3x to the x cube, you will be getting minus 3 x raised to the power 4. When minus 3x is multiplied to plus 2x square, you will be getting minus 6x cube. Now you see, minus 3x when multiplied to a, we will be getting the coefficient of x will not be having x square term. So in the place of x square term, we will leave it a blank and we will continue with the x term. Below 3x we will write the product of minus 3x and a, which is minus 3ax. Now you change the sign, add them up. Upon adding this 3x to the power 4, they get cancelled. We will be having positive 6x cube minus 4x cube. On simplification, it becomes 2 times x cube plus this x square term to carry forward. Now you look at, if you take x as common, as we have done in the previous step, if you take x as common, we will be having 3 added to 3a. So we will write this as plus 3 plus 3a times of x plus b. Look at the degree here. Degree of this expression is 3. Degree of the divisor is also 3. So we can further continue our division. Now what should we multiply? Plus 2. When multiplied 2, we will be getting 2x cube plus 4 times x square. There is no x term, so below plus b, I will write the product 2 and a as plus 2a. Change their sign. Add them. This cube term will get cancelled. We will be having minus 4 added to plus 3 will be minus 1 and minus a will remain. So I can write it as minus of 1 plus a times x square plus 3 plus 3a times x plus b minus 2a. Just look at this. The degree of this expression is 2 and the degree of the divisor is 3. So we need to stop our division at this particular step. Alright. We have got the remainder as, let me write it here, remainder. We have got the remainder as minus of 1 plus a times x square plus 3 plus 3a times of x plus b minus 2a. Remember, we have given that the zeros of q of x are also the zero of p of x. So it means q of x is a factor of p of x. Since q of x is a factor of p of x, we get a remainder as 0. Therefore, this remainder minus of 1 plus a times x square plus 3 plus 3a times of x plus b minus 2a, I will write it as 0 times x square plus 0 times x plus 0. If I write 0 in terms of x square, x and the constant, it becomes easy for me to compare the coefficients. Then only I will be able to find the value of a and b. Just compare the coefficients now. On comparison, we get minus of 1 plus a equal to 0. What does it mean? A value is minus 1. And also, let me take the constant term now. b minus 2a equal to 0. We have b equal to 2 times of a. We know the value of a, substitute, we get the value of b as minus 2. So for a is equal to -1 and b is equal to +2, sorry, -2, the zeros of q of x are also the zeros of p of x. We know the division algorithm. If we use that, dividend will be equal to divisor into quotient plus remainder. Therefore, the dividend p of x will be equal to divisor. If you look at the divisor is q of x. So x cube plus 2x square plus a. Instead of a, I'll replace it with -1 into quotient. Quotient is x square minus 3x plus 2 plus the remainder. You know, since it is a factor, remainder is 0. So let us now further write this p of x as x cube plus 2x square minus 1 times of this term x square minus 3x plus 2, this particular expression, I can split the middle term. If you split the middle term, you can write this -3 as -2 and -1. So we will be getting its factors as x minus 2 and x minus 1. Therefore, we can conclude that the zero of p of x are 1 and 2, which are not the zeros of q of x. You can think on this line why this q of x as not having 1 and 2 as a 0. You can just factorize this and cross check it. They are not the zeros of q of x. This is how this question is to be done. If you have started solving the questions of the textbook, you must have understood that most of the concepts learned in class 9 was helpful. Let's recall. I have taken some questions so that you will really understand what we had learned in class 9. Look at this question, fill in the blanks. In that first one, it's a quadratic polynomial x square plus 7x plus 12. In the next step, there are two blanks to be filled, x square plus dash x plus dash x plus 12. You have learned the sum and the product. In this sum is 7 and the product is 12. Now you can guess what should be those two numbers so that the sum becomes 7 and the product becomes 12. It is positive 4 and positive 3. By adding them, it is 7. By multiplying them, it is 12. So in the next step, I have to write this blank with 4 and this blank with 3. In these two terms, there is x common. So x is taken common. So x plus 4 remains. Plus here x plus dash. What should be written here? In this 3 is taken common. So here one more blank was missing. So we have to have this 3 here. So 3 if you take common, we will be getting x plus 4. In the next step, when you group them, if x plus 4 is taken common, x plus 4 into x plus 3. Okay. Look at the next blank. In the next, we have again a quadratic expression. In this quadratic polynomial, the product is 16. The reason is 10 multiplied to coefficient of x square. The constant multiplied to coefficient of x square is 16. Sum of the factors is 19. So now you should take two different numbers such that their product becomes 60 and the sum becomes 19. You must have guessed it. 15 times 4 is 60. 15 added to 4 is 19. So I will write this as 4 and 15. Or I will write this particular thing as 15 and this as 4. The reason is, in the next step we have a 2x here. That's possible only when 4x is written here. That's how you have to guess. So out of this 6x square and 15x, there's 3x taken common. So 2x remains and 5 remains. In these two terms, 4x and 10, if you take 2 as common, 2x plus 5 will remain. So 3x plus 2 multiplied to 2x plus 5, these are the factors. Now we will be able to understand it much better. It's once again a quadratic polynomial. 6 multiplied to minus 8 is a product of factors. 6 minus 48. Sum of the factors has to be 13. Now you have to consider two different numbers such that their sum is 13 and the product is minus 48. Then you feel it as difficult, you can prime factorize this and then find out the numbers combination. That is so easy. However, those who can guess, it's not at all difficult. 16 multiplied to 3 is 48, you know that. 16 minus 3 will be 15. So we have to consider minus 3. So when you multiply minus 3 with 16, you get it as minus 48. When you add this 16 with minus 3, you get it as positive 13. So this middle term 13 is split as 16 and minus 3. I have written here minus 3. The reason is, in the next step we have got minus 1 taken common. So if I write 16 here, 8 would be taken common, which would be wrong. So I have to consider minus 3. That's it. If 2x is taken common here, between these two terms, 3x will remain and 8 will remain. If minus 1 is taken common, 3x plus 8 will remain. In the next step, we have 2x minus 1 multiplied to 3x plus 8. These are the factors. Hope you have understood this now. This is splitting the middle term. Very important concept of class 9, also an important concept in class 10. I want you to find out the mistakes in these two polynomials factorization. You can pause the video and you can write these steps and identify where the step is gone wrong, or else take these two quadratic polynomials factorize this till the steps written by you matches with the steps which are given here. You just check it out. Definitely there will be some mistake, so only they are asked in the question find the mistake. If there is no mistake, there is no problem. You just factorize this and cross check it. Have a look at this question. We have to find the zeros of this quadratic polynomial. Very important thing to observe is these terms are not arranged in the standard format. This constant is written in the middle term. So this is rearranged. We get it as 5x square minus 8x minus 4. Now you see the sum is minus 8 and the product is minus 20. So the combination of two numbers, you have to get it as minus 8 and minus 20. Each number. If you take 10 two times, and if you have minus 10 and positive 2, we will be having the sum as minus 8 and the product as minus 20. So I will write here as minus 10 and here there is a plus 2x. In this step, when 5x is taken common, we will be left out with x minus 2. Here it is 2 common, x minus 2. So x plus 5x plus 2 multiplied to x minus 2. These are the factors. Look at the next step. For finding the zeros, we have to take the value of the polynomial as 0. So, which means in the previous step, what did we have? 5x plus 2, x minus 2. 5x plus 2 equal to 0 and x minus 2 equal to 0. So the zeros, 5x will be equal to minus 2, x will be equal to 2. So therefore the zeros are minus 2 by 5 and 2. Now you find out sum of the zeros. What will be the sum of the zeros? It is the sum of minus 2 by 5 and 2. The LCM is 5. If 5 is the LCM, we will be getting minus 2 plus 10 in the numerator, which will be positive 8 upon 5. So this is 8 upon 5. What is the minus of coefficient of x? It is positive 8. What is the coefficient of x square? It is 5. Compare this 1 and 2. On comparison, we will be able to say that they are equal. Now look at the product of zeros. Minus 2 by 5 multiplied to 2. We get it as negative 4 by 5. What is the constant term in that polynomial? It was minus 4. And the coefficient of x square was 5. Now you compare this. Equation 3 and 4. Are they equal? Yes, they are equal. This is how we were finding zeros of the quadratic polynomial, and we were verifying the relationship between constant and the coefficient. Look at this question. Find the zeros of x square minus 2. Verify the relationship between the zeros and the coefficients. Look at step 1. x square minus 2 can be written as x square minus, I will write this as root 2 times of x square, so that I will be able to use a square minus b square identity. So which formula is used? A square minus b square is equal to a plus b multiplied to a minus b. This identity is used and it is written as x plus root 2 and x minus root 2. So for finding zeros, we were equating it to 0. So the zeros are minus root 2 and plus root 2. What is the sum of the zeros? 3 is 0. What is negative of coefficient of x? In this, x square minus 2, there is no x term, or else you can write it as 0 times x minus 2. Then make this as positive, there is no problem in doing that. What is the coefficient of x? It is a 0. What is the coefficient of x square? It is 1. So 0 by 1 is 0. What will be the product of zeros? The product of zeros is nothing but minus root 2 multiplied to root 2. We will be getting negative 2. What is the constant term? It is minus 2. What is the coefficient of x square? It is 1. So we get it as minus 2 only. Let us revise some of the concepts learned. In the beginning, in our first session, we had defined algebraic expression. Let me write it here. Algebraic expression. We have understood the meaning of polynomial, and the standard form of a polynomial is given by p of x is equal to a naught plus a1x plus a2x square plus so on till an x to the power n, where an is not equal to 0. It is the standard form. In some of the books, it's reversely written. The order is changed. They will write it in decreasing order of the squares. There is no problem in doing that. The standard form can also be an x to the power n plus an minus 1 x to the power n minus 1 and continuous decreasing order, and the last term would be a naught x to the power 0. What is very important thing to notice here? The degree of this polynomial will be always non-negative integer. In other words, it has to be whole number. Otherwise, it is 0 along with any natural number. Look at this example. 3x square minus 5x plus 1 is a polynomial of degree 2. Root x plus 3 is not a polynomial. What's the reason? This root x is same as x raised to the power 1 by 2 added to 3. Therefore, it is not a polynomial because the power is not non-negative integer, it is a fraction unit. Further in our discussion, we have discussed that a linear polynomial will be having degree 1. A quadratic polynomial will be having degree 2. A polynomial having degree 3 is called as cubic polynomial. Further, I had also mentioned biquadratic polynomial, which means the degree of the polynomial is 4. Then we had a concept called as value of a polynomial. if there is some polynomial for p of x, to find the value of the polynomial for x is equal to k, value becomes p of k. We would simply substitute the value of x with a given number. Here the given number was k, so p of k was the value of polynomial. With this concept of value of polynomial, we had defined zeros of a polynomial. A real number k is said to be zero of a polynomial if p of k equal to 0. If you substitute the value of x as k and if you get the value as 0, then k is solution of the polynomial or 0 of the polynomial. We have also learnt the meaning of zeros using graph. Whenever the graph of a polynomial y is equal to p of x intersects x-axis, then x coordinate will give you the zero of polynomial. Further, we have learned that a linear polynomial has got 1 0, a quadratic polynomial has got 2 zeros, a cubic polynomial has got 3 zeros. These are the maximum number of zeros. Because in our discussion we have learned that sometimes we will have a line which runs parallel to its axis, so it means that there is no zero. But the line is a straight line, it's a linear line, a linear graph. It is for a linear polynomial. So the linear polynomial, the maximum number of zeros is 1. Same way, we had this type of graph, parabola, which was not intersecting or touching the x-axis. In this case, the number of zeros is 0. In this case, if it touches the x-axis here, there is 1 0. In this case, there are 2 zeros. Same way, the cubic polynomial will be having 3 zeros. We have also learned in our discussion the relationship between the zeros and coefficients and constants of given polynomial. For a quadratic polynomial, there are 2 zeros. If alpha and beta are the zeros of quadratic polynomial of type ax square plus bx plus c, alpha plus beta is minus b by a, which is minus of coefficient of x by coefficient of x square. Alpha beta product of zeros is c by a times c by a is constant term by coefficient of x square. We have seen some questions wherein they give the value of alpha, beta, and they will ask you to make or form a quadratic polynomial using the zeros. This is a general formula, you need to remember this. X square minus of sum of the zeros multiplied to x plus product of zeros gives polynomial p of x. We had continued this discussion and we had taken a cubic polynomial. We have seen the relation. There will be 3 zeros with alpha, beta and gamma. They are the zeros. Sum of the zeros is minus b by a. Product of zeros is minus b by a. Sum of the product of 2 zeros at a time is b by a. We have to make use of these concepts and we have to solve few questions. We shall solve few questions related to this chapter in the next session.